Evening, everybody. Here's a blast at the 2011 financial maths question. Uh, Part A was fairly handy. First payment was A, and it was paid at the start of the year, so it didn't gain any interest. The second payment uh, is A times 1.04. Third payment A by 1.04 squared for the 2 years interest that gains. Fourth payment A by 1.04 cubed, and up to the final payment of A times 1.04 to the power 25. To get all these payments into one figure in terms of A, just add them all together. Take out your factor of A, as I've done here, and then you're left with 1 plus 1.04 all the way up to 1.04 to the 25. And as usual, that's a geometric series. First term is A, R is 1, I should say. R is 1.04, and the number of terms is 26. Put that into the formula, usual formula, R to the n minus 1 all over R minus 1. And that gives you 44.3117446.2a. Best to leave it with that many decimal places because you're dividing by 21.5 million in the next step, or the other way around. So yes, just to do that step, then you're trying to find A given a 21.5 million advertised jackpot prize. So that's 21.5 million divided by the 44.311, etc., etc., which gives you 485,199. So that's the value of the payment that should be made at the start of every year, or sorry, at the start of the first year, and then it'll be increased by 1.04 by a factor of 1.04 each year. So to tie that up into a table, well, just to look at the first three terms as you're asked. The first payment, the first amount is A, which is 485,199, and the present value is the same because the first payment is at the start of the first year. The second payment is start of the second year, and that's going to be A by 1.04, which is 485,199 multiplied by 1.04, which is 504,606.96. That's the value in a year's time, though. And then the present value of that, you actually had a different percentage for working out present values given in the question as 4.78. So if you divide your 504, etc., by 1.0478, you get this figure here. And then to get the actual amount paid in the start of the third year, it's 504,606.96 multiplied by 1.04 again. And then obviously to get the present value of that, you divide it by 1.0478 to the power of 2. Just a little explanation as to where the second row figure comes from there. Part 2 then is straightforward enough. As you can see, the payment number, say for here was 3, and then here you're doing the original 485,199 by 1.04 to the 2, and here to get this figure you're doing 524,791.24 divided by 1.0478 to the power of 2. So for year 3 the exponents were both 2, and obviously for year 4 the exponents will be both 3, etc., etc. So for year n the exponents are 1 less, and they're n minus 1 for both. So after n years you get 485,199 multiplied by 1.04 to the n minus 1 will be the actual amount you receive, and in today's money you divide by 1.0478 to the n minus 1 to get the present value. Now, so it's a bit trickier than usual in that you've got two separate percentages, but it's very straightforward still. If you just remember that what you're multiplying by is you're multiplying by that divided by that, 1.04 divided by 1.0478. So that combination of those two is actually your R when you're trying to find the present value of all the payments. So the present value of the first one is 485,199. The present value of the second one is 485,199 multiplied by 1.04 divided by 1.0478 to get you the present value. And the third one is going to be 485,199 multiplied by 1.04 squared to get you this value, divided by 1.0478. So a combination, you're multiplying by 1.04 divided by 1.0478 all to the power 2, and the very last payment you're multiplying by that to the power 25. As usual, take out your factor of 485,199. You're left with all these terms. A is 1, R is the fraction, the awkward fraction, N is 26. Plug it into the usual formula, you get 11.5 million. Nothing too hard there, apart from just make careful to key in everything properly. Part E was easy. Rounding off, looking at the 11.5, she received 7.9 after tax, so she paid 3.6 million in tax. As a percentage, 11.5, easy to work out, 31.3%. There you are. See you now.